Okay, guys, so now we are moving on from confidence intervals for one mean, and today we're going to start calculating a confidence interval for a difference in two means. So this is exactly the process we used when we did a difference in two proportions, but there's honestly a little bit less work to be done because we don't have to do n times p and n times 1 minus p for both of our samples. So that kind of helps out a little bit. So in this case, we are estimating the difference in our population means by using the difference in our sample means. We're still going to use a t-score. And now, if we jump to our formula sheet, we are looking at two populations, two sample standard deviations. So we are going to do this bottom one, the square root of S1 squared over N1 plus S2 squared over N2. That is our standard error. So the square root of S1 squared over N1 plus S2 squared over N2. All right, so example 1, the Wade Tract Preserve in Georgia is an old growth forest of longleaf pines that has survived in a relatively undisturbed state for hundreds of years. One question of interest to foresters who study the area is, how do the sizes of longleaf pine trees in the northern and southern halves of the forest compare? So those are our populations, the northern half and the southern half. To find out, researchers took random samples of 30 trees from each half and measured the diameter at a consistent height in centimeters. Construct a 90% confidence interval for the difference in the mean diameter for longleaf pines in the northern and southern halves of the forest. So here we are estimating the difference in the mean diameter for pines in the northern and southern halves of the forest using a 90% confidence level. All right, now they included this breakdown of information. So we have our sample values, our sample sizes, our sample means, and our sample standard deviations for each. Because it says northern and southern, this is going to be sample 1, sample 2. All right, so let's talk about our three conditions. Random. Random samples of 30 trees. So we check that off for both samples. Independent. Certainly 30 trees are less than 10% of all trees. And then normal. Okay, so normal, we do nothing different except we just have to show that both samples were normal, which they were because 30 is greater than or equal to 30 for both. Okay, so now we start our calculations using this formula. So if we subtract those sample means, we do 23.7 minus 34.53 is negative 10.83. Plus or minus, we're taking a 90% confidence interval. So 5% is on either side. All right, so just to review, our inverse t would be 0.05. Now, in this case, to find our degrees of freedom, we would do our total sample size, so 60 minus 1, so 59 degrees of freedom. Is 1.67. Okay, and then our standard error is the square root of, here's our standard deviation, so 17.5 squared over 30 plus 14.26 squared over 30. Okay, so let's find that standard deviation. So 17.5 squared over 30 plus 14.26 squared over 30 is 4.12147. If we multiply that by 1.67, we get negative 10.83 plus or minus a margin of error of 6.88286. So we'll say 9. So then when we subtract, we get negative 17.71. If we add, we get 3.95. Okay, I'm going to give myself some space. Oops. Oh, goodness. Sorry, guys. Okay, we don't need this circle. So now let's talk about this. To interpret, we would say we are 90% confident that the difference in the means for the halves is between negative 17.71. Now let's see, these are centimeters and 3.95. Oh, and this was negative. I missed that. Okay, so our difference is always negative. So what does that tell us? Well, it tells us that the first number is always smaller than the second number. So it would not hurt to make a little note here to say southern halves, or the southern half, or even southern trees are always, oops, larger. Oh my gosh, you guys. I promise I can spell the word always. Okay. All right, so there's our first example. Our second sample talks about bags from Target. I'm not going to read the entire paragraph that is written in front of us, but basically they take a random sample of 100 bags from each store. The Target bags held an average of 12,340 grams, so N1 is 100. X bar 1 is 12,340. A standard deviation of 402. S1 is 402. Then the Walmart bag, so N2 is 100. X bar 2 is 11,700. We're down here now. And their standard deviation is 340, S2. Okay, so we are estimating the difference in mean capacity of Target and Walmart bags. All right, and we're doing so using a 99% confidence level. Okay, so random, yes, right? They filled a random sample of 100 bags. So both samples were random. Those samples are independent because 100 is less than 10% of all bags. And both samples were normal because 100 is greater than or equal to 30 for both samples. So now we calculate. All right, I'm going to shrink that all down just to give myself a little wiggle room. So, we've got the difference in our sample means. So 12,340 minus 11,700, which we could go ahead and calculate, is 640. So right now, based on just this sample, it looks like Target bags hold more because Target was first, right? But now we do plus or minus. We need to be very careful when we find this area. So if we've got 99%, then we have 0.99 in the middle. If we have 99% in the middle, then we have 0.5% or 0.5% on either side. So we bump that decimal 2 to the left, and this is 0.005 with 99 degrees of freedom. Okay, is plus or minus 2.63 times the square root of 402 squared over 100 plus 340 squared. Okay, so now we're going to find that standard error. So the square root of 402 squared over 100 plus that number came out really big, so I'm going to do it one more time. 402 squared divided by 100 plus 340 squared over 100. Yep, I'm getting 52.65 for that standard error. That seems really large, but I guess 402 squared is a really large number, so that could be why. Plus or minus 138.4699. All right, that's another reason why that would be so big. That's a pretty large margin of error, but in the grand scheme of thousands of grams, it's not that huge. So now if we subtract that, 138.4699, we get 501.53 to 778.4699. Guess you didn't really have to put the units there, right? But I did, so that's okay. Okay, we're going to shrink this down now so we can interpret. We are 99% confident. Well, not the mean, the difference in the mean. Capacities is between 501.53 grams and 778.47 grams. right? And so what's that mean? Always a positive difference means always the first number is bigger. And so to answer this last question, do your findings show evidence that there is a difference in the mean capacity of bags? Yes, they do, right? Because 0 is not included. If 0 was included, then that would be some evidence that there's no difference, that when you subtract the numbers, you get 0. But in this case, 0 is not included. So, yes, this shows, that's not Chow's, that shows, yikes, that there is always a positive difference which means that target bags hold more weight. Okay? And so that is it. That is our whole study on confidence intervals. Remember, we use them to estimate for a population parameter, whether that's a mean or a proportion, right? So the whole goal is to narrow it down to two values which encompass an interval or create an interval, and inside that interval somewhere is the actual population value for all of the population being studied. All right, I know these are tedious, but also repetitive. And so I hope that is helpful to you, that it's a process that you're just going to repeat over and over and over. But I will say, be really intentional about what each interval tells us. For example, this last one told us target always holds more. Up here, we found southern trees are always larger. When you're doing it for just one percent or mean, think about what those values tell you. So is it always really a large mean or a large percent or a small percent? So be very conscious of what those are telling you, because that is where we're headed next. We're going to keep telling the story we get from sample data about the entire population. All right, I hope Unit 6 was a good one for you, and best of luck as you prepare for your test.